Again, good morning, everyone, and welcome to the session on API security as code. My name is Isabelle. I'm one of the co-founders and the field CTO at 42crunch, which is a company doing API security, as you may guess. And here is my Twitter if you want to contact me. So what is this presentation about? Basically, as you probably know, I'm sure you've seen the news, there's a lot of problems around APIs right now. The number of breaches has been going through the roof in the past 2 or 3 years. And if you're following API Security.io, which is one of the your community sites that we have at 42crunch, where we report and educate on all this kind of problems, you'll see, very well-known brands like the one you see here on the right being hit by such problems. And if we analyze those, we'll see that there's pretty much a number of problems that always happen. And it's the combination of multiple things that make it, in general, when there is a very large breach, it's never because people have one problem, it's because they have a combination of problems. And those problems will be authorization problems, data validation problems. We still are not very good at validating the data coming our way. We trust the information coming our way, or the other way around, we're leaking information that we should not be leaking, or we have rate limiting problems. And just to illustrate that, I just took one example, which for me, it is the really example of the year, and show you what type of problems they have. Now, what are those problems? We have classified those problems in a WAFs top 10 recently to recognize the fact that indeed there are lots of problems, and there are not the same problems that we have with traditional applications. And the OWASP came up with a brand new list just focused on APIs, right? And basically there's 3 groups of problems there: authentication, authorization, again, data control, and configuration issues. So let's take this one example, which is Parler. So you may have heard about Parler. This is something like a social network like equivalent, and that came quite famous with all the Trump administration and all the problems that came around it. And became even more, famous because of this API issue. As you can see here on the right, I have a whole presentation on many different issues, and what I do is reference what kind of problems they got according to that top 10 list that I just showed. And it's probably the first one that I see that has a 6 out of 10. So what happened there, right? So this is a huge breach. We're talking about 70 terabytes of user data. And what happened? This is really the epitome of what you really, really should not do when you are exposing an API. First of all, this is completely open, no authentication to access any of the posts, which is a social network, that people are doing. So if you have access to the API, you have access to all the data. 0 rate limiting, which means if you write a little engine, then you can go and retrieve all the information. And to make that easier, all the IDs of the information is sequential. That means, like, if I'm doing a post, it's post number 1. If someone else is doing a post, it's going to be number 2, number 3, etc. So it's very easy, again, to write a little engine to go and retrieve the information. And of course, if there is no rate limiting, then as you can imagine, there's nothing stopping me from retrieving, well, a lot of data, 70 terabytes. Lots of information which is really sensitive in there, which touches on API 3 and data leakage that I was talking about before. And maybe the best one, really bad ones, you were deleting information. So I guess, after all the politics and what happened, a lot of people wanted to delete some of their posts, right? But what was happening is, behind the scenes, this would not delete the data. It would just hide it from the UI. So the data was still there, accessible in the backend through the API, which basically meant you didn't delete it at all, right? So this is really a very, very bad example of what you must basically must not do, right? Now, why is this happening? So this is an extreme example again, but there's tons of them. Well, the first thing is, APIs have changed the way we have architected our applications. We used to have architectures whereby on the server side, I would have all the logic, or like a controller layer. The data would be protected by that controller layer. And I would just expose to the client side HTML and JavaScript, basically. So the logic will not be on the client, it will be on the server. But now what we're doing is we have the same data, we're exposing it through APIs as raw data, and we count on the client side to massage that data, assemble it, and expose it, right? Forgetting that, that controlling obviously will never happen. Whatever you're doing to filter the data or anything at the client side obviously is not there, and nothing will happen if I go straight into the API and into the raw data. So other people are counting on the fact that, the client side is going to do a lot of what the server side would be doing. But if I go thread to the API, then none of this is basically happening, right? So that's one of the main problem, which is basically the new architecture. The second one is because we're dealing with data and APIs, the way we're doing application security is basically has to change as well. Because what we used to do is to build walls around our information, right? So we'll go and protect the perimeter around our company, but there's no more perimeter. This is gone, because every time you open an API, what you do is you pinch a hole in that perimeter, and you open avenues. So you have this image of the Arc de Triomphe here in Paris, where everything goes into that center. But every time I open API, there's a new avenue to that center. So what we need to protect is not so much the borders anymore. We need to protect that data and making sure that, we only expose that data to, whoever is supposed to consume it and nothing more. So it's all about protecting data now. And to make it worse, right? Well, we know that, right? We're pretty bad at thinking about security early in the API lifecycle. We tend to wait very late in the lifecycle, if any. I'm talking to a lot of prospects as part of my job. They're telling me, I know, Isabelle, I have tons of APIs, and I know some of them are going to go all the way to production and in production, and I know they have problems. But because we took on this job of fixing them, even testing them so late, I don't have the time to fix them, and I cannot block production and the release of those APIs, which have a big business impact, because maybe there is a problem and I can't prove it, basically. So it's really important that, we don't do that. We have that problem. Now, what else is wrong is we have really given the developers fantastic tools for being very productive and write APIs, like, as some AppSec people tell me sometimes, those things are popping up like mushrooms all over the place, and I have zero control over them. And one day there's 20, and the next day there's 50, and the next week there's 100. So how can we do security in those conditions? So first of all, not only do we start late, but on the top of that, there's tons of those, and they change all the time, because we are automated all the development, we have automated the deployment. So it's very easy for a developer to create something new in a matter of days, right? So we really have to equip our security people with better tools here. So plan of action. How do you make sure that we don't do this? Like, how do we address that problem? And for me, it's threefold, right? First of all, as we were just saying now, we really, really have to consider security way earlier than we were doing now, right? So as early as I would say as design time, when we're thinking about what this API is going to be, there's some things we need to think about there, and we need to consider there already, right? Then we need to really embed security into the API lifecycle. So the main problem that I hear about when we talk to developers, for example, is they say, okay, I want to do security, but I have a timeline, I have deadlines to respect. So anything that you ask me to add in there that's going to impact my productivity, that is not going to work for me, right? It needs to be something which is embedded, which is transparent, and then I will use it, but not this like complex stuff that I have to do, that doesn't work for me, right? So we have to embed security in lifecycle, but in a way that is, compatible with the productivity requirements that the development teams have, right? And the third one is we really need to put ourselves in the head of the people that will do all this hacking and start looking at things not from so much a defending point of view, but from an attacking point of view, right? So we need to start hacking ourselves, fuzz ourselves, so that we don't expect somebody else to actually do that. We're actually doing that ourselves, and we do it in a continuous fashion. So every time we make changes to the API, we discover if we have, by bad luck or bad design or whatever it is, introduced some new vulnerabilities and problems, right? So let's talk about design time first, right? So design time decisions for anything, this is a good example, are very hard to undo. If you have started designing something, you have all the blueprints, and think of this, this is a good analogy because for design, a lot of people talking about houses, right? So if you've not designed properly the blueprints of where you're going to put the doors and the windows and such arrangements in your house, once it's built, it's going to be really hard to undo. Well, the same applies for APIs. So what do we have to do? There's tons of decisions we have to make when we start working and designing APIs. So the first thing is you really have to know what it is that you're building. Security is all about risk. So, okay, I'm going to open an API for Woo. Is it something for an internal application? Is it for an external application? Is it for partners? Is it something we're going to open only to a specific set of people, like administrators, for example? So who is going to consume this data? Then what is the data we're going to expose? So is that data sensitive? Like, do we have some personal identifier information in there? Is it financial data? Is it healthcare? Is it, whatever? We need to know what the data it is that you're manipulating, right? For example, and then if it's very sensitive data, maybe we need to sign or encrypt that information. This is very common in, banking, healthcare, insurance now, where we are transporting information that potentially is very sensitive. So think you have to remember that even if you're using an encrypted channel like HTTPS, for example, once you are at the end of that channel and it stops, that data you have been transporting isn't clear. So when TLS ends, the data isn't clear. Is that okay? Is that not okay? So do I have to encrypt that information? Do I have to make sure that nobody can change that information on flight, which would require signing, right? So we need to know about that. You need to really spend the time to sit down with the business, with everyone, and design this properly. Understand, if you want, look at this as like a threat model around your API, right? Okay, so now we know what we are going to do. We probably know if this is a risky thing we're doing, what is the level of risk. And then from there, we can define the security. Different security is depending on the risk, right? So now we're going to expose, okay, what are we exposing to who? So who has access to that information? And this is where I'm going to match this to API 1, 2, 3, all the way to 10, right? So at that level, so my point is really, it's already there that you're going to take some decisions which are affecting this OWASP top 10. Again, there's some things in there. Once you have decided to do things in a certain way, it will be very hard to undo. Let me take a second point here, which is a very good example. So our resource IDs exposure. So this is this API 1. API 1 is like the top, as it says, the first problem that people have with APIs today, which is basically allowing someone to do this iteration. So let's say I have an API that allows me to see my bank account. Okay, so I'm connecting to this API, I'm putting my access token, and this is identified as Isabelle, and I'm accessing bank account 123, right? Now, if I'm trying to access bank account 124, which belongs to Guy, right, then I should not be able to do that because I'm not the owner of that specific resource, right? So you have to know about what those IDs are and eliminate maybe the risk of not putting 123, for example, of my URL, but putting /me or /my account. So I don't have a number in there. Again, as you can see, this is the design of the API. Very important, designing the data. What is the data we're going to expose? What is the data we're going to accept coming in, what is the data we accept to return. So make sure we don't take data in that we're not supposed to take in. This is something called API 6, which is mass assignment, basically allowing data to come in that we're not supposed to, or the other way around, accepting, well, actually API 8 is one of this, which is injections, the infamous SQL injections, NoSQL injections. All of that could be eliminated if we knew exactly this is the data that comes in with all its constraints, this is data that comes out with all its constraints, and anything that is not matching that will not be accepted as input and outputs, right? A lot of problems could be eliminated if we were doing this. And then making sure, I see a lot of people doing this. Sometimes for APIs, we need admin operations, like some behind the scenes operation, manage users or manage accounts across the board. Usually you don't want to mix those two things. A lot of people are putting that into the same API, and then we forget about putting access control, and then everybody has access to admin. So again, this is a design decision. What are we going to need? Where does the operations will be? How we can access those, right? And even there at design time, you need to start about operating that API. You're going to expose it. You're going to deploy it, right? Login, monitoring, very important. You need to know how this API is going to be, operated. Where will I see the logs? What is in the logs? Is there any sensitive data that we want to make sure we are not writing the logs, make sure it's not there, how we will monitor how effective our API is, how we will enforce rate limiting and make sure people cannot abuse the operations of our API, how we will manage the versions. So create a new version, retire the old one. All of that are design decisions. Many of these we will not be able to change again. If we realize we have a problem like the day before releasing the API, it will be very difficult. So you have to ask yourself all those questions. Now, how do we formalize that, right? Well, we're very lucky in the API world to have standard languages for defining what an API does and basically defining most of the requirements that I just mentioned. And this will allow us to take an API design first approach, by which I first define this interface of what, that's the contract, that I'm the API producer and I'm exposing an API. That's the contract that I'm taking, that this is what my API will do. This is the data I will expose again, etc. That's how you interact with my API. And then from there, you can create implementation, you can do automated testing. Of course, you can do documentation, which is the primary reason OpenAPI was created many years ago, but now is serving much more purposes, right? And my proposal here in this talk is also to use this as something I call security as code, right? It allows us to enable this approach called security as code. So what is security as code? If you think about what Kubernetes brought us, right? For example, it brought us infrastructure code, things like Terraform and Chef and Ansible. What they allow us to do is to describe our architecture in a static way so that we can have repeated processes, we can version this, and we'll know if we have a script that has been executed with this information and we run it again and again and again, we'll always end up with the same architecture being deployed. So same thing if you apply the same principles for security. The idea is you express the constraints of security within that static file so that you can, again, track the changes. We have something which is transparent, everybody can see, we can automatically analyze it, right? And it enables an approach in security, which is very important, called positive security model. So what is that? Right? Basically, in security today, you have two ways of looking at things. The traditional way, I would say, some tools like web application firewalls typically do is to take a negative security model. What does that mean? That means that basically we let everyone go in, right? And then we have some patterns, very much if I can make a parallel with antivirus, right? You probably, I hope, all have an antivirus on your machines. And regularly, this antivirus has to go maybe every day or maybe every hour and refresh its database of known viruses, right? So that it can look at all the data coming on your computer and matches that against the database and say, yep, I recognize this as being something bad, so I'm going to block it. That's really a negative security model. So it's all based on the fact that you have a well-known list of threats that you can recognize through signatures and patterns, and then everything that goes your way, you're going to compare it against that list of threats. Okay, so it's very threat-centric. Now, a positive security model works the other way around, which is the door is closed to everyone but people who are on the allow list, right? So this is really about knowing exactly what's going to hit you in terms of traffic, and say, yeah, this is, I know exactly the traffic which is going to hit me. I have a list. So whatever is not on that list basically cannot go through. So it's not so much focused on knowing what are the bad threats that can come your way, but rather focusing on making sure and knowing of all the things that you want to accept. So, in an API world, this OpenAPI or AsyncAPI, that's exactly what they do. They describe, this is my API, that's what it does, this is all data that comes in, this is all data that comes out. So I can use that as a positive security model for APIs, so that I can decide to reject anything that is not described in there. I also have authentication authorization descriptions in there, so I'll know exactly who I'm going to accept or not, right? And then we can focus the security and everyone within that full flow all the way from design to production, in ensuring at testing time, at design time, that this allow list is as precise, as good, and up to date as possible, right? That's kind of the idea. So that we can then use the different parts of the OpenAPI to enforce, what is the security that we're going to apply to this API? I know because OpenAPI allows me to describe that. What is the data, parameters, data formats? So, and then we have some additional things which are coming into OpenAPI. I'm part of the OpenAPI initiative. So we're working also on SLA to allow you to describe rate limiting in there, and SLAs, as well as those signatures and encryption I was talking about at the beginning, and also workflows, so that you can decide, well, to use this API, first you have to call operation A, then you have to call operation B, then you have to call operation C. You cannot consume the operation described in the API in any order that you want, right? So that will also give us another level of governance in terms and control over how the API is actually used. And if I have all this information, and I can do a lot of things, I can automate a lot of stuff. I can automate the validation of that OpenAPI or AsyncAPI file. I can do automated security testing. I have governance because now I know exactly what is the API that I have, how is it secured. I also have data governance. So this is the data that flows through my API and is controlled through that file. And anything that is not that will actually be, rejected. That's kind of the idea, right? Now, the approach I would like, to propose to you, and ideally, you should be able to do, starting with an OpenAPI definition, maybe with some extensions to describe the extra security and rate limiting, etc. I was talking about, is I'm a developer. As we said at the beginning, for developers, this all needs to be transparent and easy, right? So I'm a developer, I'm in my development environment, I'm working on my code, I'm working on my OpenAPI file, I commit this to a code repository, or maybe GitHub, Bitbucket, whatever it is, and then this starts an automated process. And as part of that automated process, I'm going to look at that OpenAPI file, what it has, what is the security in there? Is that the security which is required by the company, for example? I can do automated testing with the tools I'm going to talk about right now. I can automatically attach some security policies which are governed by my company. And I can automatically deploy the protection in place of security policies which are derived from my OpenAPI. That's really the vision, is to, rather than doing manual enforcement and rules around security, which are always a problem because people forget about them, they don't put them in place, we cannot test if those are in place or not. If you drive this from the definition of the API, then everything can come out of it, right? So this is really a movement that we see. This is something we've adopted at 42crunch, but also we see more companies doing this because I think it makes sense because we have really this ability to know exactly what the traffic is going to be. And if you can express that in text form, right, then you can do a lot of automation and a lot of analysis on top of that. And that gives you this continuous, virtuous circle of deploying a new API, creating a new API. I can have 10 a day, I can have 1,000 a day. My CI/CD pipeline doesn't get tired. It will take it and execute it. So it's not like I have an AppSec person who is overloaded with work at the end of a pipeline and has to say, this is a new API, go test it, right? So as much as we can do that is automated as the core of the testing and enforcement, then the more we can do all this in an automated way, the better we are, right? So what do we have at our disposal here today? We have we have a tool the first thing to really test here is the OpenAPI file itself, or the AsyncAPI file itself. So how good it is, because one of the key things about a positive security model is that it's very important that that description, obviously, is of good quality and reflects what the API actually does, right? And has all the constraints and requirements, again, on the data formats, on the security, etc. So you have a tool, we have an online version you can try for free here on APIsecure.io if you want to go and test it. That will give you this report on how good your OpenAPI file is, right? And then from there, you can do some fuzzing, for example, from security testing, see how the implementation of your API actually is, how resilient it is and how it works. This could be something like ZAP, which is an OWASP project. Staghawk, which is a product that's actually based on OWASP ZAP. It can be Wrestler, which is a project from Microsoft. All of these are in the references if you want to have a look after and test them yourselves, right? So what those tools will do is they will consume the OpenAPI. They will create like a graph, if you want, of all the things they have to go and test, and they will do this automatically. This can be put inside your CI/CD pipeline. So it happens every time you actually change some code, right? IDOR, as I said, BOLA, which is API 1. This is a very important, again, API 1, top of the API top 10 list. So Yelps has open sourced a project which is very interesting. It's called FuzzLighter. And what this allows you to do is to, again, you can take an OpenAPI file as input, and it will automatically go and find all those IDs. You can enrich it with your own testing. So you can, again, automatically test for those IDOR, those indirect references, this API 1 type of issues. And this is really a great project for doing this kind of testing automatically, which, again, is a huge problem in APIs today. And then, so we're also doing something very complementary on the 42crunch side, which is more about testing the constraints on the data formats, etc., from the OpenAPI files, just to make sure that at any point in time, your implementation of your API is in line with the definition you're making. So you're not making a change in the backend that is not reflected inside the contract. On the contrary, you don't have things in the contract which have not been defined, for example. So you could have some error conditions that you forgot to put inside the contract, or there are things in the contract that have been changed and need to be changed implementation. But anyway, the whole idea is, from a governance point of view, what you want to make sure is at any point in time, what the contract says, again, this is what my API is doing, and the implementation of that are in line. And you can hammer and furnish your API as much as you want. It will always answer as per the contract. That is really the idea, right? So my call to action for you is really to do this shift left movement, which is to really look at security as early as possible. And if if cost is an issue, which usually it is well proven that it's very, very hard. As I said, any design decision is very difficult to fix. So if you made a bad design decision, on the contrary, you haven't even looked at what the decision should be, adding this after the fact, it is very costly. And finding all those problems from a security standpoint very late in the life cycle is very expensive to fix. So the earlier you address those, the easier it's going to be to do technically, and the less expensive it's going to be, right? Now, hack yourselves. We said that you have to hack yourself. So this is all this testing that I was talking about. Usually what I see people doing is testing the what I call the happy path, right? So it's like, if I put some right data, the API is basically working. Maybe is a bit of testing of some data is not right, like the token is wrong, then we should not answer. That's usually being thought of. But really what you want to do is at every stage, every time you change an API, you have to hammer your API with bad data, bad formats, bad users, bad tokens, anything that can basically happen is actually something you want to test every time you make a change, because every time you make a change, you have the opportunity to do something wrong and introduce a new problem. So that's another big message. Security is not a one-time off. It's not like you test something in July, right? And you don't look at it again until September. That doesn't work this way, because in between those two things, all you get is a snapshot. And zillions of things could have changed between those two dates, right? So that's why it's so important that you do this every time something is changing. It has to be part of your pipeline, right? So it's very critical to automate security. Don't rely on manual testing every X and Y. Of course, you can do manual testing with pen testing regularly. You're not going to do a pen test every time you change 3 lines of code in your API. Of course not. And for a cost, because of the cost you will have at many different levels. But this automated testing, if everyone was doing this, like API security IO will have much less entries. That's kind of what we want, right? So our goal is, at 42crunch and in the industry in general, is just to make sure you really shift left, do all this automatically as much as possible, so we have much better APIs, much more secure APIs, and more work and less work, I would say, for all the actors around there. All right, and those are the references of the things that I've been talking about, and I'll thank you for your time today. I encourage you to go and see API Secret.io that we are curating. Subscribe to the newsletter. There's a lot to learn about all those practices and about breaches. It's always good to learn from other people's mistakes. And we'll be now taking some questions through the Q&A. Thank you for your attention.